Please, I would ask everyone to please mute their mic. But hello, everyone, and welcome to our first session for the CompTIA Cloud Bootcamp. So today we're looking at lesson 1, which is all about understanding the cloud computing concepts for today. So moving on to the next page. This lesson, we're going to be looking at a couple of things. First of all is how to understand basic cloud concepts and terms. And then for next session, which will be on Thursday, we'll be looking at how to identify cloud network and storage technologies, and also how to recognize cloud design aspects. So first, I want to start with the exam. So for those who may not be familiar with the CompTIA exam structure, for this particular exam, it's going to be a 60 minutes exam, which is a bit shorter than normal CompTIA exams, which tend to be between 1 hour 15 minutes to 1 hour 30 minutes. What also makes this a bit different is with most CompTIA exams, you have about 1 minute and a half to answer each question. But for this particular exam, you will be having about 75 questions. All questions will be multiple choice exam questions, and they will be based on performance-based questions. So in the sense that everything that we've learned today, CompTIA really wants to see your applicability to a real-world situation. Now, what makes this exam different is that the passing score is 750. So you're expected to get between 54 and above to be able to pass this particular exam, which is a little bit higher than other CompTIA exams as well. Now, for this course, they tend to say you should have about 6 to 12 months experience within the IT sector or as a business analyst or doing business management with some cloud exposure. This is not necessarily essential, but it does mean that you do have some level of understanding of cloud security or cloud concepts. However, this exam in this particular course, I would say, is very beginner friendly. So if you have no technical background, have no worries because this exam is still catered to you. Now, the exam is split into 4 different sections. So we have cloud concepts, which is about 24% of the exam. And this section might be useful for those of you who might be thinking about how to structure your study sessions and for you to understand how many sections that the exam would kind of focus on. So 24% of the exam will focus on cloud concepts, which we'll be dealing with the first week. Then the second aspect is business principles, which is about 28%, and we'll be looking at that within the second and third week. And then there is management and tech operations, which deals about 26% of the exam, and we'll be looking at that, I believe, at week 3 and 4. And then the final one is governance, risk, and compliance and security, which is about 22% of the exam. So I would say that the highest level of the exam is business principles, and then the second element is management and tech operations, and then cloud concepts, and then the lowest aspect I would say is governance, risk, and compliance. But it's still essential because, as you can see, it's 22%. So I'll definitely recommend that you don't skip that aspect. You should still kind of take it as an area that you should focus on for your exam and studying. So we're going to be talking about how does cloud services relate to business goals. And I think that this is quite essential, especially once you finish this course and you're looking at applying for roles within cloud. It's very, very important to kind of find how you're going to be able to articulate number one, what you've learned from today's session and from this certification program, but also how to translate that into your future role. So I would say that it would be good for you to have a strong technical background, but you don't need to demonstrate business knowledge. So this is who it's designed for. Also, if you have a strong business background, but you need to demonstrate your technical knowledge, just would be great for you. Similar for those who might have a strong technical background, but they don't have a strong business knowledge. Because with the Cloud Essentials, it really deals with the business management of cloud security. That is the essence of this particular certification, which is why I say it's more theoretical than more of like your technical aspect, which will be your cloud Cloud Plus, if you want to if you want to build more on your knowledge and kind of have more of a technical understanding, I would definitely recommend that after you do the certification, definitely look at Cloud CompTIA Plus certification, which really deals more with kind of like your VirtualBox and you having more technical skills in that element. I would say that if you are ready to step into a leadership position, maybe you want to step into a CISO position or in a management position, this is great because again, it deals with that business management element and it does also deal with leadership skills that you've been learning with this particular certification. Now, if you want to be able to bridge the gap between technical and business knowledge, and when I say bridge the gap, the essential skills that a lot of companies are looking at is the communication skills. How are you able to take your technical knowledge and be able to translate it to a non-technical audience? So for example, how do you show to board members or senior executives that certain decisions need to be taking place in regards to security, the type of maybe cloud network you need to use? How are you able to translate this technical knowledge to a non-technical audience? And this is what this certification will be able to help you do. Now, if you're responsible for advising organizations on cloud solutions, this is great because this certification will definitely help you to be able to do that because you'll be able to learn the different cloud models, the different cloud deployments and why, how, and in what circumstances would each model or deployment be used and why it's most suitable for the company that you're working for. And finally, if you want to demonstrate relevance to your organization, this Cloud Essentials certification allows you to do that. Again, because you're learning the business side of it, as well as the technical knowledge. So you're looking at both parts of cloud and cloud security. So I'm going to start with cloud computing. So now for us, what I would say is that if we were to dive deeper into cloud computing, it's essential that we understand its defining features. Now, I would say with CompTIA, they really, because CompTIA is an American organization, they tend to use a lot of NIST frameworks for kind of like their practice and understanding for this particular session. So I would say that the NIST, so which is the National Institute of Standards and Technology, they have outlined 5 characteristics of cloud computing. Now, I would say that look at these 5 different characteristics as the signature traits that make cloud computing what it is today. So you have on-demand service, you have broad network access, you have your resource pulling, and you have rapid elasticity and also measured service. Now we're going to look at each of these characteristics deeper before looking at the different cloud models. So when we're looking at on-demand service, I would say that when we're looking at on-demand self-service, this means users can have the provision to kind of manage computing resources as they need them without any human interaction with the service provider. So services are consumed on a as needed basis without any human assistance. This means that organizations can have provision for resources such as their servers, their storage, or their web applications as when needed. Now, a great example is imagine walking into a library and borrowing a book from a self-service kiosk whenever you need it without waiting in line and asking for a librarian for assistance. Similar, if you now go to a lot of grocery stores, you don't always have to go to a person to buy it. You can use a machine to buy your item and to leave. And that's the same kind of structure of the process when we're thinking about on-demand self-services, is that organizations can provide resources by using their own internal IT staff without having to rely on cloud service provider staffs as well. So when we're looking at the second element, which is your broad network access. So this is when cloud services are available over the network and they can be accessed through various devices. So when I talk about various devices, it means it can be accessed via PCs, laptops, tablets, your smart phones, and etc. Now, these are cloud-based resources that can be accessed, like I said, from any network. So the network might be the organization's internal local area network. It can also be a network that can be through the organization's internet connection. It can also be a network that can have a combination of both networks, which is both the internal local area network as well as organization internet connection. Now, when we're looking at cloud-based resources, they may be globally available as well. Now, I would say that when you're thinking about it, a great analogy is that think about cloud services like online streaming platforms. So, for example, if you're on Netflix, or whether you're on your phone, you can have access to it and you can watch your favorite shows from anywhere in the world. And that is kind of the same concept when you're thinking about broad network access, is that it can be accessed from a network and it's also globally available. Now, when we're looking at the third characteristics, which is looking at your resource pooling. So this is when cloud service providers have a pool network, storage, and compute capabilities. So think about it. Multiple users share a provider's computing resources, such as storage, processing power, and memory. Now, these resources are dynamically assigned and can be reassigned based on demand. So as you can see, these are allocated based on customers' demands. So because of this, you can take advantage of economy of scale. And when I talk about this, it's kind of think about a public swimming pool. Now, even though many people share the pool, there is a system to ensure that everyone gets a space to swim. So, for example, you book a time where you can go into the pool and they look at how many capacity that they have, and then they can decide whether they have space for you for that particular time. It's the same way with resource pool, where although it's a public network, there is a system that allows everyone to be able to get a space and a time to use the system. So that is resource pooling. And then we have rapid elasticity. So this is when capabilities can be rapidly provided for, or scaled in and out. So to the user, it seems like unlimited resources and it's available on demand, because the resource requirements may grow or shrink throughout the year, and the cloud-based resource can be adjusted as needed. So servers and other hardwares may be underutilized for much of the year, and then maybe during a busy period, it's going to be used a lot more. And because of that, at seasonal periods, they might need to be a higher maintenance when we're looking at cost, or higher purchase when you're thinking about cloud capabilities as well. Now, I would say, like, if you want to think about it, a great analogy is think about a balloon, right? You can inflate it when you need it to be big, and then you can let the air out when you need it smaller. So as the balloon can adapt quickly based on your needs, is the same way with rapid elasticity when you're thinking about cloud and how it works. So finally, we're going to be looking at measured service. So measured service is cloud resource utilization and is carefully metered by cloud service providers. So this is your billing for your cloud resources based on the actual use of resource. So I would say, like, a great way to think about it is like with your energy and your gas, you only pay based on how much energy you have used. Similar to this, you get billed for how much cloud resources that you have used. So with the measured service, I would say that cloud systems can measure and monitor resource usage. So this is ensuring transparency for both the provider and the consumer. So users only pay for what they use, and providers can optimize their resource allocation. So again, think about a pay-as-you-go phone, for example, right? You're aware of how many minutes you've used, and you're only charged for what you've used. So the provider, on the other hand, can track your usage patterns, and in the future, they can offer you better packages based on your utilization of their service. So same way with measured service, based on utilization, cloud providers can then offer you better packages based on your usage service. So I would say that these 5 characteristics are a great way for you to think about cloud and how it works. So I would say that understanding these 5 characteristics helps you to clarify and set cloud computing apart from other computing models. And I feel like as we progress in this course, you'll be able to see how these characteristics are realized in real world cloud scenarios and why they are so fundamental to a cloud success. So now we're going to look at the history of cloud. So I think it's very important for us to really understand cloud. It's good for us to think about the past, how it started, and the roots of cloud computing, to truly grasp the concepts of cloud and how it originated, evolved. And for us to do that, I would say that let's start from the mid 20th century. So let's start from the 1950s. Now, in these decades, computing was primarily centralized, which means there were like large mainframe computers, huge devices that would occupy an entire room. So I don't know, I think we're going to watch Hidden Figures very soon. And you'd see it, the old IBM computers, how big they were. Now, they were big because they had to process data, and individuals had to access these data through DOM terminals that didn't process data themselves, but rather displayed information from the mainframe. Now, a great way, because I know I've used a lot of terms to understand this, is imagine if each of you have your own calculator and there's one giant calculator in the school. Now, whenever you need to do some math, you will send your calculation to this big calculator, you will get the results, you write it down, and then that's kind of like how you were able to use the calculator service. Now, this is how centralized computing worked. There was one big system, which was the mainframe, and it did the heavy lifting. And then there were many smaller terminals that were able to access it. Now, obviously, things had changed. We're now in the late, 1999, when we're looking at 2002, early 2000s as well. That's when we had the rise of internet access, right? So as the internet became more accessible to the masses in the late 20, sorry, who hasn't muted themselves? Okay, done that, sorry. So when we're going back into the late 90s and early 2000s, I would say that as we had the rise of the internet access, instead of consuming local networks or isolated systems, organizations were now able to offer their services to anyone, anywhere, thanks to the global reach of the internet. Now, think about the transition from, depending on your age, from like landline phones, which were fixed in one location, and you could only access it if you were in a particular location, to now when we have cell phones where you can communicate from almost anywhere in the world. Now, similarly, we've had a widespread of internet access where services aren't just localized, but they are now available anywhere. Now, I would say that when we're thinking about when the key pillars of the cloud era began, it actually began in 1999 through Salesforce. So Salesforce was one of the earliest examples of a business adopting a software as a service. So you might have heard the term SaaS, which is SaaS before. And SaaS is basically software as a service. Now, what Salesforce did is that instead of computers buying and maintaining softwares on their own computers, through Salesforce, they can now access software hosted by Salesforce over the internet. So this was kind of like the first pioneer of cloud service as we know it today. Then now how the other element is what I would say is the Amazon Web Service, which actually started in 2002. Now, while AWS, as we know it, kind of today I would say you could say that it started in 2006, but in regards to its division and its origin, it actually started in 2002. And they were offering tools and services to online merchants. So they were laying the groundwork for what we know as AWS today. Because now, based from all the services that they were able to offer in 2006, they are now able to offer these services on a cloud-based infrastructure service, as we know as AWS, which is Amazon Web Services. Now, moving on to that, if we want to take it a step further, looking at the Google apps of 2006, this is when Google started providing a suite of productivity tools like docs, sheets, slides, available through the web, which means that users don't need to install heavy software into their computers, but now they can do it on their phone and other devices as well. Now, I will say when we're looking at the history of cloud, that it's definitely been a journey from kind of massive room-sized computers to now what we see as global cloud services that we have today. It's truly fascinating. And as we delve deeper, we'll be able to kind of see how does this foundational shift in technology, how has it shaped the digital landscape that we know today? And how can we learn from this when we're kind of understanding cloud, its functionalities, and things of that nature. So now we're going to talk about 3 primary cloud models. So the first one, which I kind of alluded to when I talked about Salesforce, is software as a service, which is SaaS. And then we have platform as a service, which is PaaS. And then we have infrastructure as a service, which is IaaS. And I would say that these are going to be your three main cloud service models that we're going to be looking at for this particular exam. I will be talking about other types just so that you have like a general context understanding of it. But for this particular exam, I will definitely say focus on these three main cloud service models. So before we kind of delve into it, I would talk about XaaS, which is basically a catchphrase for any technology solution that has moved to the cloud or exhibits that kind of pay-as-you-go subscription models. Now, as I said, the three primary cloud service models are SaaS, PaaS, and IaaS. So when we're looking at SaaS, these are software applications delivered over the web. So an example of this could be your Google Workspace or your Microsoft 365. These are software as a service because they're software applications that are delivered over the web. Now, the second part is your platform as a service or PaaS. And these are platforms that allow developers to build, deploy, and manage applications. So think about Heroku or think about your Google App Engine. Because again, these are platforms that allow developers to build and deploy their application on these platforms. And then the final one is your infrastructure as a service, which is IaaS. And these deals with your virtualized computing resources, which are provided over the internet. So this could be your Microsoft Azure virtual machine. It could also be your Amazon EC2 as well. So these are like your three different platforms, which looks at virtual machines and different parts of the SaaS. So I just got a message from Aminat that she can't see my screen. Can everyone see my screen? If you can, just give me a thumbs up. Can anyone not see the screen? Okay, so Aminat, I think you might need to maybe come out and then come back in and see if you'll be able to see the screen. But also everything that we're looking at today will be recorded as well. So please do not worry about it. So going on to the next slide. So I've talked about the three main aspects, which was platform, software, infrastructure. Now there are other aspects because with XaaS, anything can be a service and there are different aspects of it. So you have your database as a service. So these are database management delivered as a cloud service. So this could be your Amazon RDS, your Azure SQL database, and then you have your function as a service. So this is your serverless computing where developers can basically write a code that is executed in response to events. So when we're looking at function as a service, we're looking at AWS Lambda and your Azure functions. And then for number three is network as a service. So these are network services provided over the internet. So this would be like your VPN or your SD-WAN. So there are services that are delivered over network services delivered over the internet. Then thirdly, we have your storage as a service or SaaS, which is your cloud storage service. An example of this is your Dropbox or also your Google Drive, where you're able to kind of store certain items within the platform. And then for number five, we have security as a service or CCaaS. So these are security management provided over the internet. So these are your threat detection services, is your antivirus as a service. And then finally, we have container as a service, which is your container management services. So think about Google Kubernetes engine, and also think about your Amazon ECS as well. So I would say with these six, they're not going to be main things to look out for the exam, but I do think that it's good to kind of understand other elements of SaaS, XaaS, that might be able to be a great framework for you to be able to have a generalized understanding of cloud, as well as us focusing on the main primary three that we've discussed. So when we're looking at cloud service models, like I say, if you're looking at software as a service, which is SaaS here. So these are hosted applications. So again, examples I gave were your Office 365, your Salesforce, Gmail. Now, when we're looking at platform as a service, it looks at two things. It looks at the infrastructure software, and it also looks at the operating system. So at the infrastructure software, examples would be Oracle, it would be your MySQL, it would be your Java. When we're looking at operational systems under platform as a service, we're looking at your Windows, you're looking at your Linux. Now, where it does become more complicated is when we're looking at our infrastructure as a service, which is your IaaS. This is because it deals with 4 different things, right? It deals with your visualization, which is examples are your Xen, VMware, Hyper-V. It then also looks at servers and server hardware, such as your servers, your CPU, your memory, your storage. Also deals with networking, which deals with your firewalls, your routers, your switches. And then it also deals with your data center, electrical and mechanical operations when we're looking at power, cooling, physical security. All of that is under infrastructure as a service. And I think when we're looking at stakeholder and management responsibilities, you'll be able to kind of understand where you might use a software, where you might use platform, or where you might use infrastructure when looking at your cloud governance. So when we're looking at the first part, which is our software as a service or SaaS, with that, I would say that the consumer has a direct use of the software across the network. So cloud service providers retain the responsibility for underlining the hardware, operating the system, patches. What makes SaaS different is that it's usually licensed via subscription. And with SaaS, because it delivers the software over the web, it eliminates the need to install, run, and maintain software on individual computers. So because it has a top layer of cloud building or offering these kind of like ready to use applications via web browser, it's kind of very easy to use, and as such has a very high adoption rate. And it's typically kind of used when we're looking at hardware, OS agnostic, and the target audience tend to be end users. Now, a good way to think about software as a service or SaaS is that if you've ever used online tools like Google Doc, Microsoft Word Online without installing anything on your computer, that's a SaaS. So for example, when we're looking at Google has Google Sheets, Google Docs. This is all on a platform, right? This is all on the internet. You don't have to download anything in your system. And because you don't need to download anything in your system, it is seen as a software as a service. So I think another good way to look at it is like renting a fully furnished house instead of building one, because everything is ready. You just move in, start living, or start working. And examples, again, in case you didn't get it last time, is Gmail, Dropbox, even Zoom that we're on right now is a SaaS, is a software as a service, and Salesforce as well, when you're thinking about real world examples of a SaaS. So when we look at kind of going back to what I was saying, software as a service examples, Microsoft Office 365, Google Apps, WebEx, Dropbox, Netflix. These are all hosted applications. And again, looking at this infographic, we're only focused on hosted application. There's only one element to think about here. You're not having to think about other things such as infrastructure, operating systems, and other things like that. You're only focused on these hosted applications. So now when we move on to the next aspect, which is platform as a service. Platform as a service is a cloud service provider, and it retains responsibility for the hardware and operating system, and it provides platform maintenance. So a good way to kind of understand PaaS is it provides a platform for allowing customers to develop, run and manage applications. I'm going to take a bit of a break here for about 3 minutes and come back. And then we're going to focus more on platform as a service. Does anyone have any question before we go on a quick 3 minutes break?
No, for me.
Hi, Lydia. I see your hands up.
Linda, so my question is, are we going to get, in addition to the recording, are we going to get like the material you're using to teach, right? Like after every lesson?
Oh, you should have gotten the student pack, which has all of this in detail.
Okay. All right. Thanks. I'll check for it. Thank you.
No worries. Any more questions? Okay. Well, we're gonna go for a quick break and come back at 6:36. If anyone has any questions in the meantime, please put it in the chat, and then I'll focus on that before going on platform as a service. And we'll be focusing on platform as a service. Okay, I'm seeing thumbs up. So platform as a service. So PaaS is all about providing a platform that allows customers to develop, run, and manage applications without dealing with infrastructure complexities. And I think when we looked at the infographics, you can kind of see that the further you go down, the more complexities you kind of face. So with the first one, it was kind of focusing on let me go back so everyone can see it. Well, the first one, which was software as a service, it will focus in on hosted applications. Now, when we're looking at PaaS, we're only looking at infrastructure, software, and operating systems. So it allows, again, like I said, customers to develop, run, and manage applications without dealing with infrastructure complexities. It also creates kind of like a middle layer within our cloud building. So think about your cloud as a building. It provides the tools and environments that are needed to build your applications. Now, I would say for the PaaS, the cloud service provider retains responsibility for the hardware and operating system, but it does provide platform maintenance. So because of that, customers use the platform specifically for business operations, but also it can be used to provide development database platforms to the organization and developers, as well as also helping database administrator. So now I would say for the PaaS, the target audience tend to be developers and data administrators. Now, a good analogy is if we're going back into this idea of a house building. Now, if you remember what I said, that when we are looking at SaaS, it's about going into a fully furnished house instead of building one and everything is ready, you just move in and start living, right? Now, when we're going into PaaS, it's a little bit different. So I would say that PaaS is all about renting your machinery, right? So you're renting a fully stocked workshop. So you have all the tools. The tools in this case would be your development frameworks, it would be your databases, and it would also be your development tools. Now you have everything you need in this workshop all in one place without you having to worry about how to maintain the workshop itself. So going back to the analogy of this, with a software as a service, it's a house that's kind of like fully furnished. You don't really need to do anything. Everything is kind of like laid out for you. You can start living and working. While with a PaaS, it's more of a workshop, right? It's a fully stocked workshop. And within this workshop, you have tools. So the tools, like I said, going back, is development frameworks, database, and development tools. You have this all in one place. And talking about how it doesn't have the complexities that infrastructure has, it's because you don't have to worry about maintaining the workshop itself. So you don't have to worry about maintaining the platform itself. You just use the platform. The platform providers are the ones who actually maintain the platform itself. So now going into yes, I just saw for my, so it's like tools and environments to build a house. Essentially, yes. So with the house building concept, you have all the tools in this workshop to build your house that you want. So instead of it just being a house, you are provided with the tools to be able to build it to your taste. So in this case, with platform as a service, we're looking at infrastructure software and operating systems. So we're looking at those two elements. These are the two main tools that you're looking at, which is why the examples that I gave is the Google App Engine. It's a platform that you can go and you can download any app within your phone and you can use, right? But from the back end, developers are able to develop their app within these platforms and deploy it to end users. So the real customers are the developers that are creating this app for us to use within our phones. So I also like Dayo's example of PaaS being like flat packs and tools. Essentially, that's a great way to think about it. So literally, when you think about platform as a service, think about Google App Engine. You can go to the App Store, you can download any app and use it, right? But the developers at the back end are the ones who are able to utilize the tools within the platform to be able to deploy their app for us to use. And an example is Google App Engine, but you can also look at Heroku and AWS, which is Elastic Beanstalk as well. Now, finally, we're going to look at infrastructure as a service, IaaS. So this is a cloud service provider, and what they do is that they retain the responsibility of hardware support. So consumers are responsible for the management of these virtual machines that are hosted on the CSP hardware infrastructure. So businesses can deploy exactly how many numbers of servers that they need. And these deployments, going back to kind of the characteristics I talked about earlier, are elastic. And because they're elastic, they're easily adjusted to meet the agile business needs. And they may realize like a reduction in capital expenditures of for hardware as well as licenses. So I would say that when we're looking at infrastructure as a service, it provides users with a virtualized computing resources over the internet. So it's like renting the foundational building blocks that you would need to run the applications and to manage your workload without actually buying any physical hardware. So going back into the analogy of us building a house, in this example, it would be not wanting to buy all the tools and machinery. And because you're not buying all the tools and machinery in this case, rather you are renting the machinery. So the machinery in this case would be your servers, your storage, and your networks for as long as you need them. So if we go back into the different elements, with a software as a service, the house is already built and it's furnished. You just need to go and live, right? When we're looking at platform as a service, it's a workshop. So you have a fully stocked workshop where you're able to have all the tools you need. So these are your development frameworks, your databases, and your development tools. Now, in a infrastructure as a service situation, you're renting the machinery to be able to build these tools that you need to use to be able to build your house. So the machinery in this case would be your servers, your storages, and your networks for as long as you need them. And the target audience here would be your IT administrators. Now, infrastructure as a service is extremely complex. I would say that out of all of them, this is the most complex one. And that is because it deals with 4 different parts, right? When we're talking about machinery, we're talking about visualization. So like I said, examples, if you want to research it, what is it? Is a Zen, a VMware, or Hyper-V. It also deals with your servers and your servers hardware, which would be your servers, your CPU, your memory, and your storage. And then it also deals with networking, so firewalls, routers, switches, and also deals with more data centers and kind of like your mechanical operations, which would be physical, security, cooling, and power. Now, examples of this would be your Microsoft Azure. So if you guys are also studying for that with this, it's a great way to kind of understand your infrastructure as a concept, as a service concept a little bit more. Another example would be your Rackspace, as well as DigitalOcean and AWS EC2 as well, would be great examples if you want to understand infrastructure as a service concept in kind of like real life. Now, going back into anything as a service is X. So when you see XaaS, is basically anything possible as a service. So you're looking at catch-all phrases for any service that has moved to the cloud, and it can represent an overall connected service concept. So remember when I was going back in the previous example, when I talked about the different elements that could be a service, like your database, your security services and things like that, it's because it kind of fits into this umbrella of XaaS. So I see that Sasha has also added example of SaaS, going to PaaS, going to IaaS. And I think it's kind of good as well to kind of see that as you keep going, it becomes more technical and less ready-made, like she said as well, which is really, really good. There's a question, less ready-made, so requires more technical skills. Yeah, I agree with this. I do think that with infrastructure as a service, it's definitely more controllable. OneDrive, I would say no. OneDrive wouldn't be classified as an IaaS. If we go back to our examples, it would be similar to, it would be a software as a service, because OneDrive is very much similar to Dropbox and Google Drive. So it would be seen more as a software as a service example. Francine. I don't know if anyone has any more questions, but we're now going to go into a little bit more of a fun part. Just trying to move to the next slide, which is cloud components and clients. So if you saw from the previous slides, I was talking about who are the end users, who are the target audience, right? So when we talk about clients is basically who is actually accessing these cloud services. So a client can be, in the case of this exam, can be a smartphone, a tablet, traditional computers, a laptop, servers, etc., things of that nature. That will be seen as your client, because these are means of cloud services access. These are means of how you can access the cloud. When we're now looking at the second element, which is your cloud service provider data center, these are your hosts. Now, this may be distributed around the world, right? Because when we talked about the internet, you can access it anywhere. Similar to the cloud, you can access it anywhere. And then finally, when we're looking at network is the path between your cloud service and your client device, right? So it's how do we connect A to B? That is your network, is the path, is a connection. So this may include your business internal network, or it may include the internet. And again, these access points or these network points will be determined by the type of service that is being used. So for example, if it's software as a service, it would be via the internet. If it's infrastructure, it would be more of a business internal network. That's kind of like a good way to understand in which cases would you use network within the business internal network, or a network over the internet. So we're now going to go, just want to make sure I haven't missed anything. We're now going to look at cloud deployment models. Now we're going to be looking at 4 different types. So we're going to be looking at private cloud, which is services available only to a single organization. We're going to be looking at public cloud, which is when a cloud service provider owns a cloud data center and then allocates the resources to customers. So these are resources that are shared among the customers. Again, going back to the pooling, if you guys remember the characteristics of pooling, this is where it's going to be applicable. And then also computing, community cloud, which is services available to several organizations that may have similar service needs, but are otherwise autonomous. And then finally, we're going to look at hybrid cloud, which is a combination of one or two. So it could be a mixture of private and public, or it could be a mixture of community and public, or community and private deployments. So this is when there's a mixture of these elements. Now, I will say that as we delve into the world of cloud computing, we have to understand like where and how our data services resides, which is why deployment models are so important. Because if we're looking at the concept of privacy, and we're looking at the spectrum of privacy, right, which is essentially what these models are, we're looking from exclusive to personal spaces to shared to public and things like that. So when we're looking at the spectrum of privacy, cloud models function also quite similarly around those spectrum, because it's looking at the different levels of privacy, the different levels of sharing, and the different levels of customization. So when you're looking at deployment models, those are the three main things that are essential in my opinion for you to kind of understand it. Is understanding what is the level of privacy, what is the level of sharing, and what is the level of customization. And that's kind of how we explore these different elements. So when we're looking at private cloud, so private cloud is exclusively designed for a single organization. So think about this as a company's private island. So as we can see from the infographic, we have organization one and the private cloud, and then there's a straight private connection. So it's very, very easy to kind of see it in action, if that makes sense, because it's point A to point B. It's not that complicated. So now, if we're thinking about it with the example of the company's private island, this island is where all its resources and all its services are tailored to its specific needs. So it's like having a personal study room in a library, is how I'll describe it. It's only accessible to you. It's customized to your own preference. And because it's, let's say you have a specific card that allows you to access the room, it has that privacy and control, which means that only you can have access to that library room. Same way as a company that has a private cloud. So within the cloud, which is a library, they have a private room that only them have access to through their own privacy and security controls. Now, I would say that in these instances, when we're looking at private cloud in real world settings, this would probably be larger enterprises that have a need for stringent data and privacy. So these would be your banks, it would be your government agencies, it would be companies that deal with large amounts of monies. These organizations and agencies, because of their need for privacy and security, often opt for private cloud. So that's where you probably kind of like see it in real world example. So I see a question with the library room analogy. Does the organization also own the library? No. So the library is seen as a cloud. Cloud is accessible to everyone, right? But in this particular case, within the library or within the cloud, the company owns a section of the cloud, which is their private cloud within the overall cloud. Same way you have like internet, right? But you might have a section of the internet that is securely private, whether it's secured by password and things like that, only you have access to it. So but yeah, the library is the cloud, and then the room in this case would be the private cloud. Now, when we are looking at the next one, which is public cloud, so these are clouds that are shared amongst unrelated organizations, right? We have organization one, we have organization two, we have organization three. Because it's owned by cloud service provider, and the cloud service provider allocates these resources to various customers, these resources are shared amongst the customers, making it a multi-tenant environment, right? So consider, if we want to look at this with a great analogy, think about it like a public playground. Anyone can come to this playground, right? You can enjoy the amenities of this playground, you can share them with others, but you don't maintain the playground, right? The local authority maintains this particular playground. Another example is the park as well. Like anyone can go to the park. It's a public good, but the local council is the one who manages the park. You don't manage it. You just only use it when you want to use it. And I would say that in the case of a public cloud, organizations or structures that tend to go for these tend to be like startups. So organizations that are quite small in nature. So these would be your startups, your individual developers who might want scalable resources without having that huge investment upfront. So maybe they don't have the financial resources to be able to opt for a private cloud or a hybrid cloud. They will turn to opt for a public cloud because it does give them that ability to be able to kind of like utilize the resources without having such huge investment upfront. So in real life example, that's where you kind of see the elemental scenarios where public cloud can be used. Now we're going to look at community cloud. So these are services that are shared only within a specific group of related organizations, right? So the difference, because public cloud and community cloud are very similar in the sense of its resource pulling characteristic, but the difference is that with public cloud, the organizations are unrelated. There isn't a common thread within these organizations, right? It is unrelated in nature, while with the private cloud, community cloud, the services are shared among a specific group of related organizations. So in this case, the organizations are related. There is something that binds them together. So a community cloud services multiple organizations who have a common interest or a common requirement, but remain distinct in entities in regards to what type of companies they are. So an example of this would be like your different health agencies, right? Collaborating on a research project, for example. They might share community cloud to ensure that data is consistent and there's accessibility to that data, but they are different in entities. And a good kind of analogy for this would be, imagine a shared workspace or a co-working space, right? Different teams are working on similar projects, but they might share some resources like printers, meeting rooms, but each team operates autonomously. So let's say a tech co-working space, right? All the companies there are tech. They're different in nature, but they share resources such as printers, meeting rooms, and space. So that's kind of how I would describe the community cloud in its function. Yes, like WeWork. But again, when we're thinking about community spaces and things like that, the key word here to kind of differentiate it from public cloud is that with a community cloud, all the groups are related. They share a common interest. So the example I used was like a tech workspace. So because they're all tech companies, there's a specific interest. Another example I used was different health agencies. There is a common interest. So that's why they share the cloud, where they can access and use resources, but they're different in their entities. And then finally, we're going to go into hybrid cloud. So this is where it's a little bit complex because there's a mixture of cloud models. And I think that this is kind of like what we'll see in the real world example. I see Sasha has raised her hand. Hi, Sasha, do you have a question?
Hi, yeah, sorry, I've just put it in the chat. Is the fact that the communities relate, like, is a related group of organizations, is that supposed to imply that they share the same resources because they're related?
Exactly, yes. So with the example of the health agencies working on a research project, there are different agencies with their own kind of like work process, companies and everything, but they do share resources. So it could be them sharing specific health data. It could be them sharing specific databases or regulations or things like that. So because it's kind of a common interest, they share certain data and resources together, but they are different in their own entities, if that makes sense.
Yeah, it does. Thank you.
No worries.
Just put a question in the chat as well.
Hi, Francine. Okay. Hi, Francis. What about a trust NHS? Is that like a community cloud? Essentially, yes. I would say that NHS does have elements of community cloud in its process as well, because they do have to share information with other NHS entities, which might be trust or different elements. So yeah, to answer your question, it's similar. They will have a community cloud of some sort. And that's why I said, like, and I'm repeating this because this can trip you up with the exam, because in the exam they do ask questions to trip people up. It's very, very important to understand the difference between community cloud and public cloud, because they do have similar characteristics of like sharing resources amongst different organizations, but there's a difference in regards to the organizations. With community, they're related. With public, they're not related. Now going to hybrid cloud, this is any combination of the other three cloud models, and this can be more complex. And this is also, if we think about like in the real world, a lot of companies tend to use a hybrid cloud, which is a combination of the other three cloud models. So it can be community and public, community and private, or private and community, or private and public. Now, hybrid cloud model combines 2 or 3 more of the kind of previous mentioned models that I've talked about. It allows data to and applications to move between private and public clouds, offering flexibility, optimization, and deployment strategy. So a good way to kind of think about a hybrid model is think about a university campus. Some areas are open to the public, which in the case would be seen as a public cloud, and some are only for students, which can be seen as community cloud, because students are different entities, but they're all students. That's kind of the common interest that binds them together. And then there could be private research labs, which requires private cloud. Yes, they're all interconnected. So I think that might be a good way to kind of understand the analogy of hybrid model. And I'll say like another use example could be a retail company might use a private cloud for their customer data, but they might tap into public cloud for kind of power and things like that during their Black Friday sales, for example, for better scalability. So really and truly, it's case by case, but it's not, what I want to highlight is that in the real world, companies don't just purely use one model. Unless it's like military, then it's going to be mostly private. But most companies tend to use a hybrid model, so a mixture of both, but 2 or 3, but depending on the different scenarios and the different kind of situations that requires that. So for example, like I said, with the university, it's one model, but in the sense that they have public areas that might require public cloud. They have community cloud, which would be for their students, or maybe a space for their teachers. And then they will have private cloud for their private research. So that's kind of like the elements of hybrid cloud and the different ways that it can be used. I would say that the digital world is so diverse, and so is its needs. So it's important to understand, like, you know, when you're thinking about cloud, to think about the audience. Who is a target audience, right? Because a solar developer is going to have different needs from a multinational company, and based on its needs and its requirements will then determine what type of cloud structure or cloud deployment would be best suited for that company. So especially with your projects and things like that, really think about cloud model and how it's tailored to the company, and also what cloud deployment model will be a right fit for the company and in what situation. So it might be a thing where you say, oh, it's a hybrid model. In this case, I can imagine them using public. In this scenario, I can imagine them using private. And in this scenario, I can imagine them using community. And hopefully, as we kind of go more into like cloud theories, concepts, and things like that, it's very important that we will be looking at what is the critical role of cloud deployments in kind of shaping digital services and infrastructures. Because like I said, we talked about different type of cloud models, and we've also talked about the different deployments of those cloud models as well. So we're now going to look at the shared model and security aspects. So I will say that when we think about the shared responsibility, especially when it comes to cloud computing, think about cloud security as a joint effort, right? It's much like a relay race. So the cloud provider and the consumer both play a crucial role together. It's essential that both parties understand their respective duties to ensure that the baton, in this case would be like data, is safe and that it reaches the destination securely that it needs to reach. So cloud service providers are responsible for data center. So when we're thinking about data centers are cloud providers are responsible for physically securing the data center where the infrastructure is housed, right? So imagine a school building itself, and the school management ensures the structure is sound. They ensure that the gates are locked after hours and there are CCTV cameras are working, and it's kind of akin to like a physical security of a data center. Now, all these elements of protection is needed or required by the cloud provider. They're expected to provide 24 hours security on the cloud platforms and on the data that resides within these platforms. Now, when we're looking at data isolated between businesses, is that cloud providers need to ensure that one client data isn't accessible to another client's data, right? Despite being on the same infrastructure. So when we talked about kind of like the pooling resources, and in the case of like a cloud, a community cloud system, or like a public cloud, it's even, I think a private cloud less so, but with a public and community, it's very important that as many companies are using these platforms, that their data aren't, accessible to each other, that each company's data is secured and it's only that company that would have access to that particular data. So think about it as, I think a great way, if you want to think about it in reality or visualize it, is think about separate lockers, right? In a school, we're in a school, everybody has access to the school, but each person has access to their own locker. And because of that, the separate lockers in the school, even though they're all the same in the hallway, but one student cannot access another student's locker because there are security controls to ensure that each student has access to their own particular locker. So a good way, when we're thinking about this in technical terms, is visualization techniques are extremely important. So a lot of cloud providers will have visualization techniques that create isolated environments for each client. This then goes back to what we're talking about when we were looking at the infrastructure as a service. The visualization techniques are so important because it creates an isolated environment to then ensure that data is isolated between businesses. Now, when we are looking at network security within a data center, which again is the required responsibility of the cloud service provider, we are looking at safeguarding. So deals with the safeguarding of the network traffic. So it's safeguarding the network traffic and infrastructure within the data center. So if we're going back into the school analogy that I've been using, think about the school's internal intercom system, right? It can be used to make announcements within the school, but it's not accessible to outsiders. An example of this would be, again, and this would be used when we're looking at the infrastructure as a service and maybe somewhat platform, but mostly infrastructure as a service. Examples of this would be firewall controls being used in place, intrusion detection systems being used or utilized within the platform, and also network segmentation. These are key elements that are used to kind of actualize network security within the data center. And this is the responsibility of this is on the onus of the cloud service provider and not on the consumer. Now, when we're going to the cloud consumer's responsibility, and if I am talking fast, please, and you have any questions, please put in the chat. When we're looking at the cloud consumer's responsibilities, there's two elements. The first one we're going to look at is direct user access to data. So this is us looking at permissions, right? So cloud users must manage who has access to their data and what kind of access they have. So this could be, I can read this data, I can edit this data, or I can delete this data. So we're looking at read, write, and delete. And a good way could be, let's say you're in uni, for example, you're doing a piece of teamwork, and you're sharing your Google Doc to other members, in the link, it tells you what permission are you given. Is it that you're given anyone with this link to view, to comment, or to edit? If we're looking at that kind of same principles, the same thing applies with cloud, right? The user has the access to be able to change who has access to their data and what kind of permission they have to that data. So let's say, kind of like use the university example. If we're following that element in a classroom project, the group leader decides who does the research, who makes the presentation slides, and who presents, right? Each member has a role and permission. Now, an example of this on a cloud would be the user setting up role-based access control for a database where only a certain employee can modify data. So it depends. It could be the administrator, it could be the admin security team that are responsible for setting up the role-based access control, or it could be the IT team. But essentially on the cloud, the user is expected to create role-based access control for their database and for their employees or users, where only certain employees can modify the data to protect the integrity of the data. Now, going back, because I don't think I've highlighted this, one of like the holy trinities of cybersecurity is a concept called CIA triad. Now, CIA triad is confidentiality, integrity, and availability. Now, confidentiality is ensuring that only those who have like the right access, or who should have access to a certain piece of data, have access to that. So an example is, for example, let's say you go to work, you have your staff card, which allows you to gain access to the building. Is that authentication process? Because you are staff, you should have access to the building. So because of that, they're able to protect their information, their data, and their building from unauthorized users. Now, when we're looking at integrity, because confidentiality has taken place, with integrity is ensuring that the data has not been modified or edited or changed in any way. So because the data is protected, you can ensure that that data has integrity. So you know that whatever a user put is their password and username has not been changed in any way, so that data has integrity. And then finally, you have availability, which means that those who need to have access to certain data have access to it. They've been given data. And the same rule applies into this when we're looking at direct user access to data or permissions, is that in a role by the user or by the consumer setting up role-based access controls, they are fulfilling the CIA triad. One, because by the control, they're able to provide only provide access to authorized users, so the confidentiality of that data is there. Because they can decide who edits, reads, deletes, and they can only apply certain permissions and controls to certain employees, they can ensure that the integrity of their data is there, and the cloud allows them to have availability. So that is a direct user access to data and permission. Now, when we're going up to the second part, which is backup and restoration of data, this also deals with business continuity and disaster recovery management as well. So this is when users can ensure that their data is backed up regularly, that they have a way to restore it if something goes wrong. So think about it as having both a digital copy and a printed copy of your assignment. If we're using the school example, if you lose one, you have one as a backup. Same thing here. By regularly scheduling data backup on the cloud system, on a separate cloud storage and on-premise storage, you're ensuring that if anything happens, let's say your website goes down, or certain element, there's a data breach or whatever, that you're able to have access to your data because you have followed the whole process of scheduling that kind of data backup on both your separate cloud storage and also your on-premise storage as well. So this is saying that is in the onus and responsibility of the company to have like a digital backup where they back up their cloud storage, but also they have within their on-premise a storage where they also have a digital backup of the cloud data within their own company on-premise storage within kind of like the on-premise, so that they'll be able to ensure business continuity if anything happens. If a data breach happens, they're still able to continue because they've been able to back up their data. And also it deals with disaster recovery management as well. So I would say like my final thoughts on cloud, I've seen you've raised your hand. Do you want to say anything?
Yeah, it was just about the cloud consumer. So would it be like a company giving you their laptop, but you're a guest user, or you have like a specific space, but you're not like the owner of the laptop?
So I would say like with the consumer, it would be the company accessing the cloud. So as they are consumer of the cloud, remember what I said, like they, depending on the deployment, whether it's hybrid, public, or community, it's based on them being responsible for the security of their section that they've been given within the cloud. Whether that's within like a public cloud, a community cloud, or a private cloud, they have the responsibility to ensure that they set the user access controls to data permissions for their employees within the company, and that they also have a backup and restoration of data, which even that one is essential for data management within their company. Does that answer your question, Ufoma, or is there any part that you still need clarification? I'm happy to repeat.
No, I think I think I understand. It's like if you're given a company laptop and you can access the cloud on the company laptop, but you're only able to access certain elements of the cloud, similar to like when you have the laptop, you're not able to modify your company laptop. You're not able to put in like external hard drives and stuff, just those little things that they kind of do to ensure that the device is protected and you can't bring in any malware. That's kind of similar to like the cloud, isn't it? Because it's the same kind of security controls in place so that you don't mess up the company
Data.
cloud.
Yeah, with integrity. Essentially, that's and that alludes to the direct user access to data and permissions. So based on the permissions you have, there should be permission. Not everyone should have access to modify and edit the data, because if you do that, there's a security risk. So you've yeah, I like the way you explained it. I see that there is a comment in the chat. Yes, Augustina. To answer your question, yes, the role-based access is enforced by the company. So they are the ones who decide what permission they're given to each employee based on their role, security and things like that. So I know that with government, for example, your permission is based on what's it called? Your permission is based on your security clearance. So if you have CTC, counterterrorism checks, which is like one of the basic checks, you might only have access or have certain permissions. But if you have a more stringent security clearance, like SC or more developed veteran DV, then you would have a higher level of permissions. So I know that with government, if you kind of want to understand how it works, based on your security clearance is then determines like your permissioning and control, and your consumers in these aspects is the company. Now, what I will say is the company does depend on the size as well. So if it's a multinational company, it's going to be more complex. If it's a solo entrepreneur, it's going to be less complex. So again, it's kind of thinking about who's the consumer and who's the target audience. But both still have a onus to be able to have create kind of user access to data permission controls, and they are expected to have backup and restoration of their data. All right. So I think that is a final element. What I will say is like the cloud is a shared environment And security in the cloud is a shared responsibility. Again, using the relay race example that I gave, it requires both the runner to do their part, and it also requires the cloud providers and the consumers to play their roles to kind of ensure security is, being kind of developed and enacted within the cloud. So it's all about teamwork and understanding respective roles within the digital landscape, especially when it comes to security management. And kind of repeating everything that I have said before we move on is that when we're looking at cloud, they have 5 characteristics. So please look at the NIST framework example, and I think that's also within your pack, is look at on-demand service. That's a characteristic. Broad network access, resource pooling, and rapid elasticity, as well as measured service. Those are the 5 cloud characteristics. But also research software as a service, platform as a service, infrastructure as a service, and anything as a service as well. That's kind of like a recap of the key elements. If you're going to go back kind of in your own self-study time, focus on these 2 main things. And I did it like this so you can kind of understand in numbers: 5 cloud characteristics and 4 service models. And that is it for this session. I will say also added is that there are 4 cloud deployment models. So your private cloud, public cloud, community cloud, and hybrid cloud. And then also think about the shared responsibility model. What is expected of the cloud service provider in regards to them securing their data centers that they're hosting? And also, what is the shared security responsibility of the consumer, which is all about securing the data within the cloud? So it's going to be that for this session. And then I believe not next week, on Thursday, we're going to be looking at how do we identify cloud network and cloud storage technologies. Now, I would say that next week is going to be a bit longer because we have more that we're covering during that section, because I believe we're looking at topic B and topic C. Before I move on and close the session today, does anyone have any questions? Because I know that was a lot of information that I put on everyone for the last 1 hour and a half.
Where can we access the recordings?
So at the end of this session, I will be putting the recordings on the Geneva app. So it will be on the platform. So all the recorded sessions will be there. I think everyone who has joined, I have put them on the platform. If you haven't joined the platform, please do join the platform. You'll be added straight into the cloud security bootcamp section, and I'll be uploading all the resources on the platform as well. And also, if you haven't as well, please do check. So I think I've seen Elizabeth with the PowerPoints are just bullet points to the student pack. So I would employ everyone to please look at the student pack, which has more detail with everything that I've discussed today, which is for your self-study. And it also has questions for you guys to answer as well, as a way of a study technique to make sure that what we've studied today, you guys kind of have an idea of it and test yourself to kind of make sure that knowledge sticks. But please use the student pack, that online ebook. It's the holy grail for this course. With these sessions, I feel like it's a little bit rushed because I focus on the highlights and the bullet points, but the book itself really goes into detail as to everything that we talked about, and also other examples that might be more applicable in regards to your self-study as well. I see Opama still has you still have your hand up.
Yeah. Sorry, it was just about the data isolated between businesses. You mentioned visualization. What does that mean? Like when you said, oh, visualization to kind of keep them separate?
So visualization techniques creates isolated environments for each client. So visualization, what it does is it creates separate environments. So with the example I used was with students having access to a hallway, but there's lockers within the hallway and each student has access to a locker within the lockers. That's kind of like the element or the process of a virtualization within the cloud, is that the technique allows you to create isolated environments for each client. And because the environments are isolated, it means that one client's data isn't accessible to another client's data. Does that help, Ifeoma?
Yeah, thank you. Thanks.
No worries. I see Susie has her hands up. And then after
Okay.
Susie will be Sasha.
Okay. Thanks for that. That was enlightening for sure. I was wondering in terms of the self-studies, I know it's 4 hours that's recommended. Is it just a case of going over the student pack that you've kind of covered in the presentation, or is there anything that will be useful to cover as well, to kind of refresh and kind of secure the knowledge, especially from the essentials information that you've shared, or even any other resources that would just help going over and studying these ideas?
No, for sure. So I will be putting the recording of this session on the platform. And then I've also found a YouTube recording for about 2 hours that goes through these concepts as well, that I'll be adding to the platform as well for you guys to review. But with the self-studies, mostly the book and the videos, whether it's this one or the one that I'll add as well, to kind of help you with that. At the end, there will be mock exams, but that's to kind of like recap everything that we've already studied.
Okay, super. Thank you.
No worries. Sasha, I see you have your hands up.
Thank you for the lecture. It was really good. Just about the student pack with like all the Word documents, is there one for each of these sessions?
So I think there were like study notes and based on their name. So like some of them do have like the cloud concepts. So those are, I think there are about 32 of those, which kind of goes through different elements of like cloud computing history. So it's kind of like a quicker way if you're more of like, if you want things broken up, it's kind of like the study booklet broken up, but with like more real life examples and analogies to kind of help you understand it more.
Would you recommend reading these before or after the lecture?
I would always say it's always good to read it before,
Okay.
because it allows you to, because you already have like the base knowledge, and then allows you to like maybe ask more questions.
Okay, thank you.
No worries. Dio, did you have a question about visualization? I wasn't sure. Oh, visualization Sorry, Dio. I don't know if that was that a question or were you just making a point? I wasn't sure. And let me see what else. I've not missed anything. Okay. Does anyone else have any more questions?
Yeah, sorry. I was trying to understand the concept you were trying to point out when you were giving the illustration regarding the cloud security shared responsibility. So I wanted to ask, for instance, you know, we have Office 365 where people are being licensed to use Outlook and Word documents and the likes of it. Then I'm asking that in terms of trying to relate it to what you talked about, is it the same thing as in having that application, giving licensing user to use the Office account and having the admin interface that actually define the roles in terms of managing the accounts and the likes of it? Is it likened to what the description you're given?
Yes. So I think it's a way when we're looking, so in the cloud, we're looking at specific data when you're looking at direct user access to data permissions. So with the example of like with a Google Doc, if I'm sharing that Google Doc with you, I have the permission to allow you to either just look at the doc, to edit the doc, or to comment on the doc. So similar, within the cloud system, the admin will have control. So these will be around admin security, and the admin will have the control to set permissions to the data. So maybe there's specific data that's only for board level that maybe deals with more of like the intricate financial data. So they might not give normal employees access to that data. It might be no access. And then if someone's like a director level, they might have a read access to it, but they might not have the access to actually edit that data. So essentially it's the admin control or the specifically admin security team or specific members of the IT team setting the control. And the reason why this is key is by setting the access to the data and the permissions, they're able to fulfill confidentiality, integrity, and availability to that data to ensure that that data is protected, and only those who should have access to that data have access to that data. I don't know if that answers your question, Jinere, or if you need me to clarify anything.
So that's fine. Thank you very much. I appreciate it.
No worries. Does anyone have any question? I see Susie still have your hand. I don't know it was from previous. Okay.
Sorry, it was.
No worries. Any more questions? I'll check the chat just to make sure I haven't missed anything. Okay. I've just seen Osarime say that she has not been accepted. I will check that to make sure that that changes. Did you just join the app prior to this call? Sorry, oh, I don't know. You should have been accepted. I've only seen one more person has joined. But please let me check to see if we have you on the Are you Teresa on the platform? Then yes, you have been given access to the platform. You've been given access, and you should have access to the Cloud Security Bootcamp as well. Okay, so I don't think there's any more questions yet left. But if anyone has any more questions, please put it in the Cloud Security Bootcamp section, and then either me or Antonia will respond to it as well. But thank you all for coming for our first session. This recording should be on the platform sometime tonight or tomorrow morning. But thank you all for coming, and I look forward to Thursday's session. Please utilize the Excel document for studying, and also utilize the Notion platform. And I remember actually someone said that they needed a recording on how to use the Notion platform. I will put that on our Geneva app tomorrow. So sorry that I haven't done that yet. But thank you, everyone, and I look forward to seeing everyone on Thursday.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Bye.